I will see now my third video for equiangular triangles. Last we learned in a triangle, if a line drawn parallel to a side, divide the other two proportionally. So I complete many questions. Today I'll show you the problems in exercise 14.2. See we've drawn already this tree diagram. See this question in your page 84, right? Diagram is given. Prove that or show that OA is to AB, OE is to EF. A simple question. So what we learned for a triangle. In a triangle, line drawn parallel to a side, divide the other two proportionally. Those newcomers, you can't see this, but stop this, see the previous video and join with this once again. Okay, so I shown very clearly the idea, but still we not use the equiangular properties, the ratio theorem only. Okay, now come this triangle. See here, in triangle OBD, AC parallel to BD, AC parallel to BD. Therefore, what the ratio theorem says, OA is to AB. You can write as a fraction form or ratio. I write the ratio. OA is to AB equal what here? OC is to CD. OC is to CD. I say number one. Number one result. For this triangle, apply the ratio theorem. Now come to this triangle. It's not pyramid. This is not a pyramid. Two different triangles, right? See now here. In triangle ODF. For the data, CE parallel to DF. CE parallel to DF. Therefore, what? In a triangle, a line drawn parallel to another side, divide the other two proportionally. That means what? OC is to CD. OC is to CD. Or like the ratio form. OC is to CD equal what? OE is to EF. Say number two. Second results, number two. Okay. Now connect the both. See what happened here also. OC is to CD. There also OC is to CD. These two are equal. Therefore, they arrive in conclusion we call axioms. Therefore, other side is equal. Therefore, show 1, 2. From 1, 2 is the answer. OA is to AB equal to OE is to EF. Straight is actually part 1 or 2 marks question, right? In triangle, a line drawn parallel to a side, divide the other two proportionally. Okay. Right. See next question. This diagram. For this diagram, show that AC is to CE, BD is to DF for the given information, right? But here no triangle, because our lessons, our chapter under the triangle theorem. Here no triangle. Therefore, we have to prepare a triangle by joining the lines. That's called construction. So can I join this line? It's a construction, join AF, right? Construction, join AF. And I make a name for this. I mark this, what is that? G. I say that is G. Okay. Now take this triangle, write the ratio. Lines are parallel. The big figure is a trapezium shape. There is no straight theorem for trapezium. I prepare a triangle, right? Then take triangle AEF, write the ratio. In triangle AEF, in triangle AEF, by the construction the CG parallel to EF. Okay, CG parallel to EF. In a triangle line drawn parallel to another side, divide the other two proportionally, right? Therefore, AC is to CE, AG is to GF, write that. AC is to CE equal AG is to GF, okay? I say number one, first result. Now take the other triangle, other side, come to that in triangle ABF. In triangle ABF, right? But that GD parallel to AB, right? Or that straight line, GD parallel to AB. GD parallel to AB, data. Therefore, write properly the ratio theorem for that triangle. Here see AG there, GF there. So you also, can I write from that up to downwards, okay? AG is to GF equal to what? BD is to DF, okay? AG is to GF equal to BD is to DF. So write that. AG is to GF equal BD is to DF, okay? Say second answer, second result. Just continuously watch this whole video series, that they knew well what happening today now. Otherwise like a magic. Better you stop, complete video number 1, 2 hands come to this. Now connect the both. You also ACC, AGGF. You also AGGF. Therefore, these two parts are equal. So arriving a conclusion, this is equal. Therefore, other parts are equal. Right? Therefore, 1, 2. From 1, 2 give the answer. AC is to CE equal to BD is to DF. That's the idea. Straight ratio theorem, right? In a triangle line drawn parallel to a side, divide the other two proportionally. Okay? Now see the third diagram, third question there. Here also so many parallels given, show that AP is to AB and BR is to BC are equal. Same ideas, you take so many parallel, proper one pair of parallel, that means pair of parallel, take and complete the ratio. Take the other pair of parallel, take the other ratio and think how to get this answer. Maybe one thing comes common part. Okay. So here, in triangle ABC, PQ parallel to BC, PQ parallel to BC, right? Therefore, what the ratio theorem? AP is to PB, AP is to PB, what equal to AQ over QC, AQ over QC, okay? Okay, that I say number 1. For a one pair of that parallel, we can obtain such a result. Now take other, it's the parallelogram. Some question you need this also. Parallelogram idea also we have to apply in the future problems. Okay, so opposite sides are parallel, it's called parallelogram. Now we did just two parallel. See like this. AQ, QC, BR, RC, the order important. Here also we have the AQ, QC. They have better start from the AQ, QC. Start the AQ, QC start, right? Now see in triangle ABC. Once again, triangle name is ABC, but the inside inner parallel different. QR parallel to AB, parallel to AB. Therefore, the third time I am saying that ratio theorem. In a triangle, if a line drawn parallel to a side, divide the other two proportionally. Therefore, what is that? start from here. AQ is to QC. AQ is to QC equal to what? BR is to RC, right? BR is to RC. Okay, I say number 2. See, what is the answer here? AP, AP. See, there's a problem. There's a problem. AB here. And BC here. There's a problem. It's not the problem in the question. Not the problem is wrong. We'll try to improve that. Okay, now see it's both. But they are arriving a result. Conclusion. Here AQQC, also AQQC. These both are equal. It's straightforward, right? Therefore, the other pair, other side is equal, right? Right now, that one. Therefore, from 1, 2, from 1, 2, you write it. What is that? AP is to PB equal what? BR is to RC. BR is to RC. But in the answer, AP is to AB. Other side, not BRC, BC. So there's an important part. You have to show the idea, how to connect that one. So ratio we can write as a fraction form also. Last 2 video I forward that fraction type any ratio can be used as a fraction. Then only solving equation is easy ideas we use. Therefore, in this case, now I convert this ratio to fraction, right? What is fraction? Tell the fraction form. What is that? AP over PB equal to what? BR over RC, right? RC. Okay. In the answer, we need the AP, but there's no PB. Check, there's no PB. There's no PB. Here there's no RC, okay. Therefore now small changing, I write the reciprocal, write both sides reciprocal. These both are equal, therefore its reciprocal also equal, right? Write that therefore PB over AP equal RC over BR. Okay, it's both the same, both same idea, but I show this, therefore I want to change to this pattern. Now, AP is okay, there's no the answer here. There's AB, no AB here, the same as other side, no BC. So now this step you have to study properly. Now, you add one both sides. Add one both sides, important note. Add one both sides. Add one both side. In an equation, we can add both sides. We can subtract any number, same number. You can multiple same number both sides. Add one both side. So PB over AP, add one. Okay. This is wrong if I add here also. Therefore, add the other side also. RC over BR, add 1. Okay. Now simplify with something LCM idea, algebraic fraction pattern, multiple the LCM here. PB plus AP over what? AP. Here what? RC plus BR over what? BR. Now see what the fraction, what the addition of that. What happened? PB plus AP. PB plus AP, that is AB, that is AB. Okay, AB over AP, right? Equal. Alright, other one, what is that? RC, BR, both addition, that is BC. Check that, BC over BR. Or otherwise the fraction give as a ratio pattern. What is that? AB is to AP equal BC is to BR. Okay, is the answer? Yes, this other side. But change both same. 1 is to 2 means 2 is to 1. Change and give or leave it, no problem, same idea, right? This question meaning very important, adding ones, new term, new pattern we use first time. I think you use that in O-level class, grade 11 chapters. Add one, some question here subtract one also. So in a triangle, if a line drawn parallel to a side, divide the other two proportionally. Is the ratio here. They were asked to prove this earlier, before 2000, as a proof necessary in the exams. But now the application only. The same, the converse also true. If the ratio is equal, ratios are equal, lines are parallel. If you learn the midpoint theorem in schools or anywhere, the converse of midpoint theorem also equal. Converse, pratiloma. If two lines are parallel, a transversal cut, alternate angles are equal. What is conversely? If alternate angles are equal, lines are parallel. So converse also true. Let me reverse. So next exercise we apply those things. Now we can see that the 14.3, page 87. Take the page 87, see next questions. So this platform of YouTube is easy to learn because wherever you can refer it, you can switch on your computer, laptop or mobile phone, you can revise it, right? So many call to me to work Zoom, the technology or Google Classrooms. One lesson I make in the advanced combined maths. Later I thought it's the best thing in the platform technology to use it because you can't refer the Zoom. Once again, you can't review it, I think. You can't review that or revise the Google Classrooms, only that duration. Therefore, I hope the best opportunity is wherever midnight or daytime, wherever you can revise this by your own your laptops, you can revise it. So take full opportunity than the other Zoom, Google Classrooms is best. Only problem this here coverage or the data. Same as the Google also, that classrooms you need a good powerful Wi-Fi or that mobile data. Anyhow, take full opportunity. I think this is the best thing to addressing the students straightly. Also they can revise after many months or close by to exams also. That one you can't, that's all. The teacher finishes the lecture or finishes teaching. Hereafter none you can't work. You think what he said, what he thought. If I noted only, you can get opportunity. But this is very neat. Straightly you can take a forward part of this. You can get high knowledge, I think. So keep in touch. I release many videos in A-level combined math different on my channel. I release I think 25-30 videos that's watching all over Sri Lanka. Many connect with me. Same as this, you can forward it to anyone, anybody, your colleague, that your friends, classmates, relations. Okay, take the other. I show that converse theorem problem. Very long lesson, so I'm going to explain all the question and to go let it go. So 14.3 diagram. Diagram is given. A, B, C, year 16, year 12, 20, 15, this is PQ, centimeters given. Based on the information, show what PQ parallel to AC. Here no parallel, we have to show. Easy question. If you are very clear with the previous problems, the reverse, we call converse theorem. In a triangle, if a line drawn parallel to a side, divide the other two proportionally. That's the theorem we worked. Now we say, in a triangle, if a line divide the two sides proportionally, divide the two sides proportionally, then the lines are parallel. Simple, right? And now see that BP is to PA equal to what? BP 16, PA 12. Okay, I get the simplest ratio cut by what? 4. 4 is to 3. Okay, now take the other part, BQQC. BQ is to QC, what equal to? 20 is to 15. 20 is to 15. Divide by 5. Divide by common factor 5. What is that? 4 is to 3. So what is this? Both the same ratio. Therefore, BP is to PA equal BQ is to QC. Is it? Ratios are equal. Therefore, lines are parallel. Therefore, PQ parallel to AC, right? Clearly identify how to apply the reverse of that theorem. Converse theorem, right? Go through and see next question. Draw a diagram, mark the details. Stop the video. Stop the video, try on, mark the diagram, at least draw a diagram and mark the details. Triangle ABC. Point P lies on the side AB. Okay, mark somewhere here. P lies on AB. And Q lies on the AC. Somewhere here. I mark, right? Such as AP is to PB equal AQ is to QC. Okay, therefore if I draw this line parallel, the triangle ratios are true, therefore PQ should come parallel to the BC. The question is QBC, QPB angle, P, yes. Very simple thing, you are grade 9 maths. You know that if two lines are parallel, this is 110 degrees. What is the angle? What is the angle? 70 degrees. Sum of the allied angle 180 degrees supplementary. If I say here 100, what is this? 80. Because parallel. That's the idea. So there's some notation just to complete this ratio part and tell the lines are parallel. Therefore, sum of the allied angle supplementary 180. Do that. So we can write the AP is to PB equal AQ is to QC. Given that. Given that. Therefore, tell that PQ parallel BC, right? In a triangle, line drawn parallel to a side. Divide the other two proportionally. If it's proportional, then the lines are parallel. Okay, lines are parallel. Now this is parallel. You can't mark. Don't mark in the diagram. You tell. So I'm explaining. So what happened now? Therefore, these two angles are 180 degrees. Supplementary angle. Then tell that answer. Copy this expression answer. Therefore, QPB angle plus here lower PBC angle equal to 180 degrees. Give within brackets sum of the allied angle. Give the answer sum of the allied angle. Next question, that's one of the past exam paper, those very old paper. Okay, how that triangle, draw the big triangle. is named as ABC. ABC triangle, and there's a point X like this. And here a point P, here a point Q that is jointed. Here a point R jointed. They mark these two parallel corresponding arrows, one single arrows, and here different double or dark arrow. That's all. You have to show BC and Q are parallel. BC and Q are parallel using our theorem. In a triangle, if a line drawn parallel to a side, divide the other two proportionally. So parallel available. Therefore, we'll start the problem. Once you start only, you can get the answer or part of answer. Okay, can I take the triangle ABX first? In triangle ABX, in triangle ABX, PQ parallel AB, or I can say, yes, PQ parallel to AB. Okay, PQ parallel to AB. So what the ratio theorem therefore? XP is to PA equal to what? XQ is to QB. Don't mix the ratio. If you start from here, here start from here. If you start up from downwards, here from here to there. Okay, so can I say XP? XP over PA equal XQ over QB, right? I say number one. First ratio using that triangle. Take another pair is available here and the parallel available here. Take that one. In triangle, what is that? AXC. See, in triangle AXC, PR parallel to AC. PR parallel to AC. Therefore, what is that? XP is to PA. XP is to PA. But what? XR to RC. XR to RC. Okay. I say number 2. See 1 and 2 what happened? See the 1 and 2. This is number 2. Here also XPPA. Here also we have the XPPA. Therefore other sides equal, arriving a result. Here this left hand sides are equal. Therefore other side right hand side equal. So 1, 2 gives you therefore 1, 2 is what? XQ over QB. XQ over QB equal XR over RC. Okay. See, if I am raising this part, XQ, I am raising everything. See this triangle? Any idea of this triangle? This triangle. For this triangle, if anybody says XQ is to QB equal XR to RC. So what can you say? What is your result therefore? XQ is to QB equal XR is to RC. That means ratio theorem, converse theorem therefore. So if ratios are true, therefore lines are parallel. Then right, therefore QR parallel to BC. QR parallel to BC. That's the method, right? That's the way how to prove this question. Okay, from next video, we don't start the equiangular triangle. We show only the ratio problems now. Next video, I will show the similar triangle calculations or otherwise equiangular idea and more problems available. Expect that videos to finish that lesson successfully, right?